Good afternoon to all. Today I am going to spend a lecture on extraction of aluminium, and my outlines are introduction, properties of aluminium, Bayer's process, and finally uses of aluminium. Okay. So before coming to the extraction of aluminium, I will discuss some important points about aluminium. So what is aluminium? Aluminium is a very important non-ferrous metal and play an important role in the economy of a nation. Particularly for India, it is very important as it gives certain financial help to the country. What is that financial help? Now, India has very good aluminium reserves, and from that reserves, India exports aluminium ore to the outside country, and from that India gets revenue. So this is a economical part. Now I will come to the real extraction part. So aluminum is a important metal, as already I have told you, and aluminum is the most abundant metal in the earth crust. After silicon and oxygen, it it is the most abundant metal, sorry, it is the most abundant element in the earth crust. Aluminium possesses 8% of the earth crust. Now what is aluminium? It is a soft metal and the color of aluminium is silvery white, and it possesses very good corrosion resistant. It makes 8% of the earth crust, and the bauxite ore of aluminium is the main ore from which we extract aluminium. And the other important points of aluminum is that the atomic number of aluminum is 13, atomic mass is 27, the melting point of aluminum is 660 degrees centigrade, density is 2.7 gram per cc, and the symbol of aluminum is Al. Okay. So properties of aluminum. Aluminium possesses a ductile character and it is a soft metal. The color it is also a aluminum is a very good conductor of heat and electricity. It is a non-magnetic metal, and the melting point of aluminum is 660 degrees centigrade. Boiling point is 2060 degrees centigrade. The crystal structure of aluminum is FCC, which is known as face centered cubic, and aluminum is a very important metal. Why? Because the strength to weight ratio of aluminum is very high as compared to steel. Okay. Then we'll discuss some important ores of aluminum. What are the different ores of aluminum? First of all, I would like to say that aluminum possesses so many minerals like cryolite, bauxite, gibbsite, diaspore, corundum. These are the important minerals of aluminum, but we cannot extract aluminum from these minerals. So we have to extract aluminum from a particular ore. What is that ore? That ore is known as bauxite. So what is bauxite? Bauxite is a mixture of monohydrate and trihydrate of alumina with varying amounts of silicon oxide, titanium oxide and iron oxide. So what is monohydrate of alumina? The monohydrate of alumina is known as diaspore, and the trihydrate of alumina is known as gibbsite. So it is a combination or mixture of gibbsite and diaspore with other elements like titanium oxide, silicon oxide and iron oxide. So this is the important part of aluminum extraction, that is ore of aluminum. Next we will go to what are the different areas where we can get these aluminum ore reserves. In general, aluminum ore reserves are found in various countries of the world. They are first India, then Russia, United States of America, France, Guyana. All these important countries possess aluminum ore reserves. Out of these, India has a high percentage of bauxite ore. So where we will get bauxite ore in India? In India, we will get bauxite ore from the state like Odisha, Jharkhand, Chhattisgarh, Tamil Nadu, Maharashtra. And in Odisha, we get it from Damanjadi area where we can get bauxite ore. In Chhattisgarh, we get it from Amarkantak area. In Jharkhand, we get it from Ranchi. In Maharashtra, we get it from Kolhapur district and also in Tamil Nadu. So these are the areas from which we get bauxite ore. Then we should know what are the different aluminum industries available in India. So nowadays aluminum plays very important role in our daily day-to-day life. So some of the important industries I would like to say, number one is National Aluminum Company in Odisha, that is available in Onugul district, also in Damanjadi. Then comes Hindustan Aluminum Company, which is situated in Hirakud of Odisha. Then uh, Hindustan Aluminum Company in Renukoot of Uttar Pradesh. Then Bharat Aluminum Company in Korba district of Chhattisgarh. Then Vedanta Alumina in Odisha. So these are the important industries available in our country. Now, now we'll go to the next point, that is how this aluminum is extracted or produced. So for that we have to know three steps. By using these three steps we can produce or extract aluminum. Number one step is concentration of bauxite ore, which is also known as purification of bauxite ore. By purifying bauxite ore, we will get a pure alumina from which we can get aluminum. Then second step is electrolytic reduction of alumina, which is also known as Hall-Héroult process. In this process, we have to reduce the pure alumina to get the aluminum. And final step is refining of aluminum. Refining of aluminum is done by a process known as William Hoopes process. By using these three steps, we can extract aluminum. First step is known as purification of bauxite ore, or you can say it concentration of bauxite ore, which is known as Behr's process. What is Behr's process? It is nothing but the purification of bauxite ore to get a pure alumina from which we can extract aluminum. So in Behr's process, this is given the flow chart or flow sheet, and now I will describe the flow sheet so that you can understand how this process is carried out. First of all, the bauxite ore which is obtained from the mines is crushed and fined in a jaw crusher and hammer mill. After that, what happens? After crushing and fining the bauxite ore, we will go to another step in which the bauxite ore is converted to -100 mm size by using a mill which is known as ball mill. In a ball mill, what happens? In a ball mill, we put that bauxite ore, fine bauxite ore, and sodium hydroxide solution, which is known as caustic soda, is put into the solution, and after that a slurry is formed. That slurry is sent to a digester. That slurry is sent to a digester which is known as autoclave. What is autoclave? It is a and it looks like a big pressure cooker. You know pressure cooker, and if you convert a small pressure cooker into a big pressure cooker, that will behave as a autoclave. And in that autoclave, leaching takes place. While leaching is taking place, we have to add caustic soda solution as well as steam, because this makes that solution perfect. And after that, what happens? After that, pregnant liquor is found, which is known as also hot liquor, which is known as also hot liquor. And in that leaching solution, what happens? Alumina is dissolved. Alumina we got from the bauxite ore, that is dissolved in the solution. But some important other materials which cannot be dissolved are iron oxide, titanium oxide, and little bit silicon oxide. That undissolved part we have to look into it. So after that pregnant liquor we got or hot liquor we got, we sent this hot liquor into a settling tank, into a settling tank where this hot liquor is settled down, where this hot liquor is settled down, and the settling time is around 4 to 5 hours. The settling time is 4 to 5 hours. In that settling process, we add starch. Why we add starch? Because starch makes the settling quite speedier. That means it speeds up the settling of the process. So after some time, after 4 to 5 hours, we get a red mud solution. We get a red mud solution. Why it is called red mud? Because in that solution iron oxide is present, which is known as hematite, and the color of that hematite is red. That's why it is called red mud. And red mud is separated. How the red mud is separated? By washing. By washing, the red mud is separated and the dissolved part is also separated. And that red mud contains iron oxide, that is around 57%, silicon oxide around 10%, aluminum oxide, that is alumina, around 17%, and other impurity material like TiO2 and etc. After that we wash that mud. After washing, what happens? Again that red mud is clarified. Then comes filtration process. After that we filter so that we can separate the dissolved part and the undissolved part. That undissolved part is separated as red mud cakes, and dissolved parts comes as hot liquor. Then this process is repeated. Again filtration is done, again red mud cake leaves out, again hot liquor comes. After that hot liquor comes, we put that hot liquor in a heat exchanger where this is little bit from that heat exchanger we leave out the effluents, and after that we cool that hot liquor to below 100 degrees centigrade. Initially the temperature was around 180 to 200 degrees 220 degrees centigrade. Now our job is to cool down that hot liquor to below 100 degrees centigrade. So why we will cool down? Because we have to get a precipitate. So after that we will do the precipitation. Then after precipitation the thickening process will carried out. Then after that we will get a important material that is called alumina hydrate, Al2O3 hydrate, which is, what is hydrate? Hydrate means that alumina contains water, and our job is to remove that water from the alumina so that we will get a alumina which is anhydrous, and that can be carried out by using a process known as calcination. So we have to dry this alumina hydrate by using a process calcination, and that will be carried out in a furnace which is known as rotary kiln. In rotary kiln we will dry the alumina hydrate at a temperature about 1200 degrees centigrade to 1300 degrees centigrade. After that we will get a product which is called anhydrous alumina. What is anhydrous alumina? That means this alumina is pure and it doesn't contain any impurity. and it is water free. That means there is no water involved. So this is the first step. So we have completed the first step. First step means bare process. In this process, we have produced a product that is called pure alumina, and that pure alumina will be used in the second step. What is second step? Second step is electrolytic reduction of pure alumina which is found from the bare process. And this second step process is also known as Hall-Héroult process. Hall-Héroult have discovered this process in the year 1886, and they established a formula. What is that formula? That pure alumina found from the Beers process will be used in Hall-Héroult process to get a pure aluminium. So how we will get? For Hall-Héroult process we will use a steel tank. We will use a steel tank, and the size of tank is, it is 5 meter length, 2 meter wide and 1 meter deep. And in this steel tank we will produce pure alumina. In this steel tank we will produce pure aluminium. So how we will get? So first we will fill up the tank with cryolite. After that we will add alumina to the tank, and that tank consists of so many things. Now I will discuss what are the requirement of the Hall-Héroult process. The requirements are cryolite, alumina, ash-free carbon electrode, electric power, and other solution. So the ash-free electrode is uh, used as anode, and the steel tank has a lining. The lining consists of carbon bricks, and which is acts as cathode. When you add alumina to the cryolite bath, cryolite slowly melts. What is the importance of cryolite? Because it decreases or reduces the bath melting temperature. So after some time, what happens? The cryolite melts. While the cryolite melts, we add slowly alumina to the cryolite. So after some times reaction will occur, then the carbon electrode will be decomposed. That anode will be decomposed and aluminium will be formed. The molten aluminium will move away from the tank in a way in the bottom part of the tank. So we get that aluminium, and here the some factors that affects this process or this bath are the density of the bath, temperature of the bath, current density, interpolar distance. These are the factors which affect the bath composition of the Hall-Héroult process. So in Hall-Héroult process, we get the aluminium which is pure, but our purpose is to get aluminium which is 99.99% pure. So for that purpose we have to use another step, that is step number 3, which is known as refining of aluminium, and that refining is done by a process which is known as William Hoopes process or three layer process. And here in Hall-Héroult process, what we get? We get a pure aluminium, but that aluminium is pure up to 99.5%. But our aim is to get aluminium which is required for our electrical purpose, for our electronics purpose, that is more than 99.99% pure. For that we go for refining of aluminium by using William Hoopes process. In William Hoopes process, there is a important thing we have to know. What are the important thing? Number 1 is the requirement. The requirement are a electrolyte, then comes the temperature, electrode. All these things are important. Current. These are the requirement for William Hoopes process. So the electrolyte that is present in the William Hoops process consists of cryolite 30%, aluminum fluoride 36%, barium fluoride 18% and calcium fluoride 16%. This electrolyte forms the middle layer of the bath. Why it is called three layer? Because this process consists of three layer, that is bottom layer, middle layer and top layer. The middle layer consists of the electrolyte which has a density of 2.8 and the top layer consists of impure metal which has a density of 2.3 and the bottom layer consists of copper and aluminum alloy which is heavier and the density is 4.5. So as we know, by comparing copper and aluminum, copper is more nobler than aluminum. So the more nobler metal will be deposited and the less nobler metal will be dissolved in the solution. So copper is deposited at the bottom and the aluminum is dissolved in the solution. So after some time we will get the impure metal, that is copper, which is deposited, and the dissolved metal, that is aluminum, we get it and from the bottom layer, and that aluminum is more than 99.99% pure, and that aluminum can be used for our electrical and electronics purposes. Okay. Now finally we'll come to the last part, but that is the most important part, which is known as uses of aluminium. Where is aluminium is used? As I have already told you, alumina is a very important metal for our daily life. Without aluminium we cannot live our life. So aluminum is used in our transport industries like our bus, truck, car, all these important vehicles. And it is also used in a house, building, all these parts, and also in food industries for our packaging purposes. In the food industries, we use aluminum, and in our houses, we use aluminum doors, aluminum windows. All these building parts are used by aluminum. Next comes extraction of manganese and chromium from its oxide. While we are extracting chromium and manganese, we use aluminum for that purpose. Then comes household appliance. Household appliance means in our house, in our kitchen we use aluminum mostly. Our utensils are made by aluminum. Our electrical appliances, our other important appliances used in the home are also uses aluminum. Then comes electrical transmission. For electrical transmission, aluminum is the most important metal because it is used for transmission purposes as it is a good conductor of electricity. In comparison to copper, aluminum has a very good conductor of electricity and it is also a low cost metal as compared to copper. So we use aluminum in our electrical transmission lines. So so this is briefly I have discussed about extraction of aluminum, and you all be aware of these things, and I think you have understood little bit from my lecture. Thank you very much.